Hello everyone and welcome back to our data structures with Python lectures. Today we're going to look at insertion, and before we look at that I want you to remember that the next things that we're going to look at are the insert at the beginning, insert at the end, insert at the middle, deleting a node, and searching for a node. Now search is going to play a major role with inserting at the middle, which is going to be for next week. So in this week we're going to look at inserting at the beginning and the middle, but this part, this insert at the middle, is going to be kind of a simpler method that search is going to make much better in the future. So looking at the last lecture that we have, we saw that we can create a node, which is a class that has 2 points, data, and a pointer called next. And we're going to use those nodes to create our linked list by connecting them together. We declared that we had something called a head, which is a pointer that always points at the beginning. Then we did a very simple method for printing a linked list. This method traversed the linked list, which means it started at the beginning of it, at the head, and ended at the end. In the last lecture, after we created this object from the class linked list, we created some nodes by hand and connected them together. We said that that method is fairly simple. It is not the correct way to do it, and we just did that as an example, just for an example's sake. Now today we're going to learn the correct method to insert. This week's lecture is going to be into 3 parts, each one of them covering a type of insertion at the beginning, at the middle, and at the end. So to start with inserting at the beginning, I'm going to stay within the linked list class in here. I'm going to give it a small comment, so inserting at the beginning. And I'm going to define my method in here, and I'm going to call it insert at start. So inserting at the start of my linked list. And when you insert something, especially with linked list, normally we're going to need a location, but with inserting at the beginning, you're not. All you need is just the data. So I'm going to need self and data. That is because even if you send me the location, this is called insert at the start or insert at the beginning. So no matter where you are, I'm going to start at the beginning, insert it there. And I already know that location because I know head. And head is always going to look at the beginning of my linked list. So what I'm going to do in here, let me just clarify this. Okay. So what I'm going to do is start by asking the question of, is this the first node? Now, if we look at this, I'm using Microsoft Visio here to give it some visual examples. So we have an empty screen, and this in reality is our linked list. We don't have a linked list. In here, I have an if statement that's going to say, if my linked list is empty, then do the following. If not, then do the following. And I'm going to start with the if statement. So I'm going to say, if my linked list is empty. How can I know if my linked list is empty? Well, this head in here, self.head, if it is still pointing at none, that means it's pointing at nothing. So I'm going to use a small circle in here. This is a big one. Small circle. This is the head. So this is my pointer that always points towards the first location. Right now, it's pointing towards nothing. None. So because it's pointing towards none, that means there is no linked list, and you can see that in here perfectly. And I'm going to ask the same thing. If self.head equals none. If it was none, what I want to do is create that linked list or create that first node and point toward it. So I'm going to say the following. Okay, what do I need to create a node? I need the class. I have it. I can create an object from it, and I need data. Again, I have it. I don't need anything next to it because we just said if it was none, then it is empty. So all I need is the data to create it. And I'm going to do that. I'm going to say new node equals create a node from that class with this data. So let's say that this data in here is the number 5. And I said if statement is self.head is none. And right now it is pointing towards nothing. It's none. And I said, okay, then new node equals create a new node with data. Then data equals 5. So I'm going to do this. I'm going to say, okay, create a new node with data of 5. Let me increase this quickly. Not that much. Okay, so right now, new node equals, let me take this to the side in here to make it easier. Okay, so new node, this is the new node, equals create a new node we did with the data, number 5, we did. Now let's ask the same question again. Is self.head equals none? What do you see in here? Is it pointing towards anything? No, it isn't. It is still none. And that means if you create a million nodes and you didn't point towards them, from the computer's point of view, you are still with an empty list. You still have an empty list because the head, which the computer uses to start at the first location, is still pointing towards none. Let's change that. It is really, really simple. Self.head equals my new node. I'm saying, hey, dude, you, head, do you see this? We just created it. Okay, point towards it. And now we're going to point towards it. So as you can see, we created it in here. Self.head equals new node. We pointed towards it. Now, when you ask the following question, is self.head equals none? No, it isn't. This is not none. This is a node with the data of 5 in it. So this is the case of I have nothing in my linked list. This is the case of my linked list is empty. But what if someone sent data to insert at the beginning, a node to insert at the beginning, and we had something in our linked list. It wasn't empty. So I was going to say, let's say the same scenario that we are seeing right now, someone sent the number 3 in here. And it's asked, is self.head equals none? Is this none? No. There is something that it's pointing towards. So all of this if statement is not going to work. It's going to jump to the else. Now, we're going to do almost the same thing, but we're going to do something a little bit different. When you look at the new node, let's first of all create it. So I'm going to say new node, just like we did earlier, equals node, create the node with data. So data that we sent in here is 3. So I was going to take 3, put it in here. Oh, I want 20 to make them the same. Okay, so we did this. New node equals node with data. Create a node with my data. Now, I want to make this the first. If I take the head and make it point here, because head always points towards first, that means this is going to be deleted. And we as human, we are looking at this on the screen and we know that 5 exists. But to the computer, it's going to get lost. It doesn't know where that 5 is. So instead of doing that, let's first of all point from 3 to 5. And I'm going to do this in here. I'm going to say the new node that I just created, I wanted to point the next pointer of it. I wanted to point towards the first element in my linked list. Okay, where is that first element? How can we know it? Well, it's very, very simple. Head always points towards the first element. So if we say, okay, new node, this new node, dot next, the pointer of the new node equals self.head, then what we are doing is adding this connector in here. We're saying, hey, point from here to here. But from the computer's point of view, the first item in our linked list is still number 5 because the computer is going to come to head and ask, okay, where are you pointing? I'm pointing here. It's going to say, okay, this is the start, and goes to the wherever the next is pointing of that 5, of this node. So what we need to do is change this also. So I'm going to do self.head equals new node. Do you see how simple it is? I just said, no, look, right now, self.head point towards the first node. You see how simple this is? Now let's do that again very, very quickly. Let's take another example with the data equals 0. So I'm going to say, is self.head is none. Is this right now pointing towards nothing? No, it isn't. It is pointing towards something. So leave the if, jump to the else. Create a new node with the data. We said in this example, data is 0. Again, create a new node with data. So this data is going to be this data in here. It's 0. What I want to do right now is do the same thing again, which is new node, the one that I just created, equals self.head. Where is self pointing right now? It's pointing in here. So I want to do the same. My new node dot next pointer, point toward where the head is pointing, and then switch the head connector, self.head equal new node. I'm going to do that in here. And as you can see, we are adding always at the beginning of our linked list. And we did from the nodes, single nodes, create an actual linked list. So what's next? It's very simple. Let's go to the object that we created earlier and do the following. List.insert at start. I'm going to take the same numbers just for the example's sake. So 5, copy and paste. I'm going to do 3 and then 0. Of course, we need to print it. So list dot our function was called, I remembered, as print linked list. I hope I'm not mistaken in here. And let's just run it. Okay, and you can see 0, 3, 5. Switch it 0, 3, 5. I hope this lecture was kind of amusing for you and informative, and I'm going to see you again when we insert at the end of the linked list.